Hello everyone, welcome to attend our class. Today we are going to study section 6.9, Design Method of Ordinary Bolt Connections in Channel. In this lesson, we will study the carrying capacity of a single ordinary bolt in section 6.9.1 and the carrying capacity of ordinary bolt group in section 6.9.2. And the action of shear force. The bolt is subjected to the action perpendicular to the direction of the screw X. The failure mode of the bolt connection and the action of shear force may be that of the bolt is cut off. Assuming that the shear stress on the shear surface of the bolt is uniformly distributed, the shear capacity of the bolt can be arrived by this formula. Obviously, the shear capacity of a single bolt is related to the section area of the bolt, the design value of the shear strength of the bolt, and the number of the shear area of the bolt. The larger the cross-section of the bolt is, the higher the shear strength design value of the bolt is, and the more the shear area of the bolt is, the greater the shear capacity of a single bolt will be. Since it is difficult to determine the actual bearing stress distribution of bolts, it is assumed that the bearing stress of bolts is distributed on the plane of the bolt diameter. To simplify the calculation, the stress on the bearing surface is assumed to be uniformly distributed. Therefore, the design value of bearing capacity or bolted connection can be obtained by this formula. Obviously, the design bearing capacity of a single bolt is in direct proportion to the diameter of bolt, the total thickness of bearing member, and the design bearing strength of bolt. And the action of external tension force. The contact surface of the member tends to separate, and this time the bolt is subjected to the pulling force along the X direction. So the failure is the split of the bolt bar and tension. The position of tensile failure is usually located and the section weakened by the thread. So the design value of tensile bearing capacity is calculated according to the effective section diameter of the bolt. The design value of the bearing capacity of a single tensile bolt can be obtained by this formula. And the action of axial shear, the average shear force per bolt is equal to the total shear force divided by the number of bolts, which must be less than the minimum shear capacity of the bolt. The number of bolts required is equal to the total shear divided by the shear capacity of one single bolt. In addition to checking the shear bearing capacity of the bolt, it is also necessary to check whether the net section of the connected plate meets the bearing capacity requirements. The tensile stress on the net cross-section is equal to the axial force divided by the net cross-section area, which must be less than the design value of steel strength. That's all for this lesson. See you next time.